Hi students, in this session we are going to learn about the trivial or the common system of nomenclature of alkyl halides or the haloalkanes and giving importance to the prefixes like iso, neo, secondary, tertiary, okay, and then en, right. So we are going to give importance for all these prefixes in this session, right. So, before learning this common system, we should know what are haloalkanes, how they are formed. Actually, these haloalkanes, they are formed from alkanes. Actually, when a haloalkane like a methane, CH4, okay, this is the first alkane, right. When one of the hydrogen atoms is replaced by a halogen, we will get haloalkane. Okay, see, for example, if you are replacing one of the hydrogen atom from this methane by a halogen, halogens will be normally represented by the symbol X. Okay, so when you are replacing this, we will get CH3 X. Okay, so this is a haloalkane or alkyl halide. Okay, normally this haloalkanes are represented by the symbol or X, where X represents the halogens like chlorine, fluorine, bromine and iodine. Understood, students? Okay, next we are going to see the rules which we are going to follow while naming the common system or the trivial system of nomenclature of haloalkanes. Now we are going to see the rules to write the common naming of haloalkanes. See, to write the common naming of haloalkanes, actually we are having three parts, right? Prefix, word root and suffix. So, a prefix we will see next. Before that we shall see what is word root and suffix. Okay. So, actually word root is nothing but the name of the alkyl group. How do you arrive at this alkyl group? See, if that is the alkane, alkanes. So, see here alkane, you want to remove this A from alkane, you should remove ANE and then you should add the YL. So, after removing hydrogen atom, you will be getting the alkyl group, right. So, for example, if it is methane, if it is the parent alkane is methane, you should remove ANE and you should add YL. So, this is the word root. Okay. So, this is how you should write the word root. And what is suffix? Actually, suffix is the name of the halogen which ends with IDE. Okay. So, halogen, for example, chlorine, if the suffix is chlorine, okay, if the suffix is chlorine, you should remove this Ne minus Ne and you should add De. That means it will be written as chloride. Okay, so chloride. If the replacing halogen is bromine, then you should write as bromide. Okay, so this is how you should write. So word root should be alkyl. For example, methyl chloride. If it is CH3Cl, then you should write as this is alkyl, word root. So methyl, okay, alkyl, methyl, this is chlorine. So it should be written as chloride, methyl chloride. Okay, so this is the basic one. Now we are going to see the different types of prefixes which should be added in front of this word root. So see the prefixes, students. The first prefix is en. When we should make use of this prefix en? See, the prefix en is used for alkyl group having continuous chain of carbon atoms with no branching. See, if we should make use of this en, prefix en, when the alkyl group is a straight chain. Okay, it should be a straight chain and without branching. There shouldn't be any side chain or branching. So, for those compounds you should give the prefix en. For see here, this is the first compound. See here, CH3Cl. Okay, so this is methyl, right. The parent carbon is alkane is methane, right. So the corresponding alkyl group is methyl. So next one is chlorine. So chloride, methyl chloride. Okay, so the name of this compound is methyl chloride. Okay, methyl chloride. Now This is the common naming, right? Methyl chloride. See, this is a straight chain. There is no side chains or branching. So here you can write the prefix N. Okay, N hyphen methyl chloride. Check this compound, students. See how many carbon atoms are here? 1, 2, 3. So it is the corresponding alkane is propane. So what could be the corresponding alkyl group? It is propyl. Okay, propyl. Okay, so propyl, P-R-O-P-Y-L, propyl bromide. Okay, propyl bromide, right? So here you can write, since it is a straight chain, here you can make use of the prefix N. Understood, students? Where to make use of this prefix iso? See, this prefix iso should be used for those alkyl groups in which one methyl group is attached to next to the end carbon atom. See here, this is, let me explain this with an example. See, this is the main chain, okay? This is the main parent chain. See here, we could see one methyl group attached to the carbon atom which is next to the end carbon. Which is the end carbon here? This is the end carbon. So, next to this end carbon, we are having another methyl group, okay? So, if we are seeing a methyl group next to the end carbon, we can make use of the prefix iso. Okay, so how to name this compound? See, iso hyphen, how many carbon atoms are here, students? 1, 2, 3. So 3. So that means propane. The parent alkane is propane. So what could be the corresponding alkyl group, students? It is propyl. Okay, P-R-O-P-Y-L, propyl bromide. Okay, bromide. So this is the name of the compound, isopropyl bromide. So students, prefix neo should be used when two methyl groups. See, in the iso we saw one methyl group, but here it is two methyl groups. Two methyl groups are attached next to the end carbon atom. Okay. See, check the example here. See here, this is the end carbon, right? This is the last carbon, right? So next to this end carbon, we are having two methyl groups. When two methyl groups are attached, to a carbon atom which is next to the end carbon atom, we call that group as neo. Understood? We call that as neo. So this is neo, right? Now we can make use of the prefix neo hyphen. Now check the number of carbon atoms. 1, 2, 3, 4, 5. Is it not? So 5 carbon atoms. 5 carbon atoms means the name of that alkane is pentane, right? Pentane, right? Now what could be the corresponding alkyl group? It is pentyl. Okay, alkane minus ANE plus YL, so pentyl. What is the functional group here? It is bromine, so bromide. Understood, students? It is neopentyl bromide. Okay, this is how you should make use of the prefix neo. If students, this prefix secondary should be used when the functional group means the halogens. Here we are looking into haloalkanes or alkyl halides. So here the functional group should be halogens. So the functional group is attached to the carbon atom which is attached to two more carbon atoms. That is a secondary carbon. What is secondary carbon? See, the secondary carbon is a carbon atom which is attached to two more carbon atoms. Understood? Two more carbon atoms. When a carbon atom is attached to two more carbon atoms, we call that as secondary carbon atom. Okay. Now, if the functional group, see here the functional group is bromine. If the functional group is attached to a carbon atom which is further attached to two more carbon atoms, see this carbon is directly attached to two more carbon atoms, is it not? So we call this carbon as a secondary carbon. If so, if this is the condition, if the functional group is attached to the secondary carbon, we can make use of the prefix secondary. So here we can make use of the term secondary, SEC, okay, secondary. Now check the number of carbon atoms, students. 1, 2, 3, 4, 5. 5 carbon atoms. That means the corresponding alkane is pentane. So the corresponding alkyl group is pentyl. Okay, pentyl. Now secondary pentyl. What is the functional group here? Bromine. So bromide. Understood, students? This is how you should write. So here, look here, students. Prefix tertiary is used when the functional group is attached to the carbon atom which is attached to 3 more carbon atoms. See the previous one, that is secondary, is a carbon which is attached to 2 more carbon atoms. Here it is 3 more. See, look at this example. See, the functional group bromine is attached to a carbon atom which is attached to 3 carbon atoms. That means this carbon is a tertiary carbon. This is a tertiary carbon. Understood, students? That means this we can make use of the prefix tertiary here. Okay. Tertiary, this is the prefix tertiary. This functional group bromine is attached to a carbon atom which is further attached to 3 more carbon atoms. Okay, so here we can make use of the prefix tertiary. So now check the number of carbon atoms. 1, 2, 3, 4. Is it not 1, 2, 3, 4? So what could be the corresponding parent alkane, students? It is butane, right? So corresponding this is butane. Now what is the corresponding alkyl group? It is butyl. Okay, butyl, tertiary butyl bromide. Understood, students? So this is the name of the compound. Hope you might have understood all the prefixes now, right? Okay, we shall see some of the review exercises or some of the questions, how to solve the questions now, right? So give the common name for the following. So we are going to give the common name or the trivial name for the following compounds. We shall see the first one. See, check the number of carbon atoms here. 1, 2, 3, 4, 5. Okay. So 5 carbon atoms are here, and all the carbon atoms are directly attached. It's a straight chain. So if it is a straight chain, then we should make use of the prefix N, is it not? So N. Now how many carbon atoms? 5. That means it is pentane, right? The corresponding alkane is pentane. So the corresponding alkyl group should be pentyl. So N pentyl. What is the functional group here? Chlorine. So chloride. Okay. N pentyl chloride. So this is the answer. Understood? Next we shall go for the next question. See here, check the functional group where it is attached here. Check the number of carbon atoms. 1, 2, 3, 4. This is the longest chain. So longest chain this here. But check the side chain. See here, 2 methyl groups. 2 methyl groups are attached to a carbon atom which is next to the end carbon. This is the end carbon, right? So 2 methyl groups are attached to a carbon atom which is next to the end carbon. That means it is neo, right? It is neo. The prefix is neo. Okay, the prefix is neo. So neo. Now check the number of carbon atoms, students. Total number of carbon atoms: 1, 2, 3, 4, 5, 6. So 6 means hexane. So hexane, alkane is hexane. What is the corresponding alkyl group, students? It is hexyl. Okay, hexyl. Now the functional group is bromine. So bromide. Okay, so it is neohexyl bromide. So now we shall see the next question. See here, see where the functional group is attached. Check the functional group where it is attached. The functional group is attached to a carbon atom which is attached to 3 more carbon atoms. Is it not? See, this is one, this is another one, and this is another. So this carbon atom is directly attached to 3 carbon atoms. That means it is tertiary. If a carbon atom is attached to 3 carbon atoms, then we call that as tertiary. So the functional group is attached to a tertiary carbon atom. Is it not? So the answer is, the prefix could be tertiary, tertiary hyphen. How many carbon atoms are here? 1, 2, 3, 4, 5. So 5 carbon atoms. So 5 means it is pentane. So the corresponding alkyl group is pentyl. So tertiary pentyl chloride. Understood, students? Okay. We shall see the next set of questions now. See, write the structure for the following alkyl halides. Some of the alkyl halides are given and you are asked to write the structure. Okay, reverse, right? Now, isopentyl iodide. Isopentyl. Iso means a methyl group is attached to a carbon atom which is next to the end carbon. So let us write the end carbon here. Next one is another carbon. To this carbon, one methyl group is attached. Okay, so this is iso. Now pentyl. Pentyl means there will be 5 carbon atoms totally. So 1, 2, 3. Now you should write 2 more carbon atoms. Okay, 2 more. So we have given the skeleton now. Now you write the number of hydrogen atoms. So here 1, 2, 3. Already 3 bonds are there. So one more hydrogen we need to put here, so that the valency will be satisfied for carbon. The valency of carbon is 4. So now 1, 2, 3, 4. Now check this carbon. How many? Here 1, here 2. So you should add 2 more hydrogens. So 4 valency is satisfied. Check this carbon here. Here we should write iodine because it is isopentyl iodide. Okay. So now check the valency of this carbon. 1, 1, 2, 3. Is it not? Only 3. So here you should write 2. Okay. So this is the structure of isopentyl iodide. Hope you might have understood. See here, what is iso? Iso means a methyl group will be attached to a carbon atom which is next to the end carbon. Of course, here we are having a methyl group near to the end carbon, right? So this is the structure. Next, secondary butyl bromide. Secondary means the functional group will be attached to a carbon atom which is attached to 2 more carbon atoms. That is secondary carbon atom. Okay. So the functional group will be attached to the secondary carbon atom. So we'll write the skeletal structure now. Butyl. Butyl means methane, ethane, propane, butane. So 4 carbons. 4 carbon. We shall write the skeleton first. 4 carbon. Secondary. Secondary means in the secondary position. See, this is the secondary carbon because to this carbon 2 more carbon atoms are attached. Okay. So here we'll write Br. Okay. So to the secondary position we have written. Now we shall balance this. See how many, what is the valency of this carbon? 4. So 3 will write 3 here plus 1, 4. Now here, see 1, 2, 3, 4. Okay. Now this carbon 1, 2, again we should write CH2 so that it will be a balance. Valency will be satisfied. 2 hydrogen, 1, 2, 3. Okay. Here again we should write 3 CH3 because CH3 plus 1, 4. Okay. So this is the structure of secondary butyl bromide. See here, the functional group bromine is attached to a carbon atom which is attached to 2 more carbon atoms. So this is secondary butyl bromide. Next one is the easiest question. Okay. N-butyl chloride. N-butyl. N, where we make use of this N to a straight chain. Okay. Butyl. Butyl means methane, ethane, propane, butane. So 4 carbon atoms, is it not? So 1, 2, 3, 4. We will write the skeleton first. And chloride. So here we can write Cl. Now you write, this is CH3, CH2, CH2. Okay. Here what is the, okay, CH2. So 3 plus 1, 4, 2 plus 2, 4, 2 plus 2, 4, 2 plus 2, 4. Okay. So everything satisfied. So this is the answer. So you might have understood all the answers, students, questions, how to solve the questions. Before signing off, this is Anitara, Geochemistry Mentor. In the next session, we shall see the IUPAC system of nomenclature of haloalkanes.